Okay, this is going to be the video for section 3.2 homework. Okay, this first problem I didn't go over too much in class, so let's make sure we're good. The symbol for the sample standard deviation is going to be S. Population standard deviation is going to be this little funny thing. That little symbol is called sigma. The sample variance is going to be S squared. And the population variance will be this little sigma squared. So just make sure you're comfortable with those notations. Okay, so what we want to do, tells you how to do it, but what we want to do here is get, let's see, the range, the variance, the standard deviation. Okay, so let's just open this up in StatCrunch. No. Not true. Okay, good. Whew. Okay, so what we're going to do is hit the stat button, summary stat, columns. Okay, select columns. Select the column we have our data in. Then we come down here and N is our sample size. We don't need the mean. We need the variance. We need the standard deviation. We don't need the standard. We need the range. We don't need the median. I think that's it. So let's try it. And let's go ahead and compute that. Okay, so I got standard deviation 9.5. Type in integer or decimal. It didn't tell me to round, so hopefully they'll give me this. Sorry, the range. Duh. Okay, the range was 23.8. Sorry about that. Okay, this should be better. There we go. Okay, here we go. The variance. Variance is 90 point. Okay, 2 decimals. 90.34. Okay, and usually what I'll do once I'm on here, on a computer, I would just cut this thing and I would copy it. Okay, I guess I'll show you in the next one, so let me do it. The standard deviation of the sample. So something like this. I'll take this whole thing, copy it, see if it'll work. Yeah, it's not going to let me do it, but you could copy and paste it. So 9.5, 0. I don't really need the 0, but I'll just put it. Okay, good. Okay, so the top 10 annual, okay, well this wasn't randomly picked. So I'm going to say no because it wasn't like a representative sample. These 10 were like the top 10 annual salaries. So the top 10 people shouldn't be a good representation of the TV personalities in general. So that's why I went with C. Okay, so the coefficient of variation is essentially it's just, you could find it in StatCrunch the same way. Let me just make sure what bank we're dealing with. Okay, we need bank A. So I'm on the A list. So I'm going to go stat, summary stat, columns. And I'm going to get the B one too, just because I know that they're probably going to do that. So I'm looking for coefficient of variation. Just get rid of this stuff. Yours is a little different. There it is right there. Okay, and so 6.92. How many decimals do we need? Okay, 1 decimal. So So that's 6.9. And notice they have the percent sign right next to it, so don't change this into a decimal. Okay, same thing. 24. 24.6. I'm gonna double check that. 24.62. So it says round to one decimal, so I go to the second, I go to the 6 and the 2, and I'm looking for the 2 to make sure that it's less than 5. That would keep the 6 there for the rounding. So that should be right. Okay, good. Okay, is there a difference in the variation? Okay. The waiting times at B is less very good. I would say the waiting times at bank A are considerably less variation than B, because it's a less percentage. So a less percentage implies less variation. Okay, so let's go ahead and run this data. So the question is going to be asking for the range, the variance, and the standard deviation. The range, so stat, summary stat, columns. Pick the one list that you want. So we need the variance, standard deviation, and the range. So let me get rid of this other stuff. And I'm going to find the average too. And I'll show you why we need the average, because I read the second part of the question. Okay, let's compute that. Okay, so that's for range first, 3.55. Okay, so we didn't add the extra value. Standard deviation 0.6. It's a pretty small standard deviation, so 0.655. See how many decimals to that? 3. So 0.655. I usually put a 0 first there. It's not that important, but you don't necessarily have to do it. Okay, this is going to be the variance, 0.429. Okay, so now what I'm going to do is I'm just going to come over, I'm going to open the data set back up, and all you have to do is just come down here. And then just add whatever they want. So they want us to add a 7.5. Okay, good. And then just do the same thing over again. Stack columns, select. So what we want is everything. We want these 3. Oops, want the range. Compute. So that's with the value. So the range went way up. Standard deviation, I thought, should have went up too. That's kind of weird that the standard deviation went down. Oh no, 0.79. Standard deviation went up. Okay, good. Variance went down. That makes sense. Variance should have went up too, but yeah, variance went up too. Okay, so I'm not going to go all the way through this. You should kind of see what to do. Just put in the range, put in the variance, and put in the standard deviation. Let me make sure it doesn't do these values, the variation change much. Okay, well, let me just get to that point. So we get to that last question, 6.36. Okay, standard deviation, 0.794. Variance, 0.631. Okay. Okay, the ranges. Huh. Are within 5 percentage points of each other. I'm not really sure what they're asking here. The variances are, I'm going to say, within just about by 3. This is sort of a bad one, so I won't ask you this one. So if you watch this, know that I won't ask you that. Okay, I think I see what they're saying. I'll explain it to you. So, if you did something like how much of a percent increase something did, you would do like the old or the new minus the old divided by the old. So that would be like the percent change, which is maybe something from an algebra class or something. With the extra diet range. So this one went from 3 to 6, so it almost doubled. So I'd say that's definitely more than a 5%. Which I'll show you what it means here. So I'd say something like this. I would say, okay, new, which is, this is the new range, minus the old range, and divide this by the original. So if you figure this out and you're looking, hey, is this more than 5% or less than 5%? And that's definitely more than 5%. This is definitely going to be bigger than a 5% increase. Okay? So that should be more than. Now we have to do the same thing with the, who do they do next? Oh, I think that messed me up. No. Okay, so I'm going to say, I'm just going to kind of do it based off logic. The variances. So it went from 0.4 to 0.6. I'm going to say more than for that too. And we went from 0.65 to 0.7. I'm going to say more than there too. So I'm going to say they're all were significant. Me hitting that button kind of messed me up. Oh, there we go, there we go. Okay, good. They were all pretty significant. So you had to do that for all of them to make sure that they were all bigger than 5%. Okay, good. A rule of thumb. This is something you have to be good at. Okay, use the F-scale measurements. Okay, the range is 5. The range of thumb is the estimate of standard deviation. Okay, let's look to see what's going on here. Open these in StatCrunch and see what I'm dealing with. So what I'm going to do is just find the standard deviation, and hopefully that's what they want. I hit the wrong button. Okay, back. Let's just find standard deviation. So standard deviation 1.153. Okay, now I know that there's going to ask me for rounding, but the decimal rounded to one decimal place. 1.153. So that would be 1.2. Hopefully this is right. Oh, okay. So range divided by 4. There you go. So there's the range. So 5 divided by 4. That's not too far off. 1.25. So they want you to do the range divided by 4. This is a different type of a measurement of standard deviation. That I didn't know was on here, so don't worry about this question. Range divided by 4. The range is 5. That's 4. Oh, it's 2 decimals, sorry. So it's 1.25, so they want me to go to 1.3. It's a silly system sometimes. Okay, the actual standard deviation is 1.15. That's within. So 1.15, 1.3, it's within 0.5. Is not. Okay, so they have this other ways to measure spread where just do the range and divide it by 4. It's like cutting the data up and then finding like 25% of the length and calling that the standard deviation or an estimate of the standard deviation. And the real standard deviation, which is 1.15, and then this rule of thumb says 1.3, so that's 0.15 away if you do the math. So it's within 0.5, which isn't that big of a deal. Okay, now this is going to be more important. So this is the empirical rule. Approximately what percent platelets are within 2 standard deviations? So this is that thing that I brought up in class. And I'm just going to do something real quick. Okay, sometimes when I do that, I can't move forward to the next problem. So that was the thing I did in class. I'm trying just a little bit more important. It's when I do this. And we put, see, I can't scroll over anymore. So this is the mean of 258. Just move it, then do it this way. 0.6. And then the standard deviation is 63. So what you would do is get this point. This point is like 258.6 plus 63.3. This point right here is 258.6 plus 63 plus 3 plus another 63.3. Or you could just take this point and add 63 point to it. Okay? Now you're going to do the same thing, but you're going to minus it. Here you're going to minus it. Okay, so, and what percentage falls in there? That's 2 standard deviations this way, 263.3 this way, and 263 this way, so that should be 95%. Now you can look at your notes, and I gave you this thing split up, and it was like 34, 34, 13.5, 13.5. So if you add all those up, you should get 95. Okay. So now we have to go from 195 to 321. 195. Okay, so 195 to 321. I'm hoping this is 321 without pulling out my calculator. I'm hoping. 258. Okay, maybe that's too big. Let me just try to do it in my head. 258 plus 63 should be in the low 20s. Okay, this is 321. So this one here should be 321. Okay, and this one here should be 195.3. So this is 1 SD. Over here is 1 SD. If you add these two numbers up, you get 68. And there you go. Okay, so what measures are most centers of extreme values? The range. The range is the max minus the min, so if you get a big number, it'll mess up. It'll mess up the variation. Okay, so that's called the empirical rule. Within 68% shall fall within one standard deviation. That's the thing that I just had on that graph. Okay, this is a good question, 3.2. Sorry. Trying to move forward. Okay, I like this one, 3.2.41, number 6. Don't like that. I don't like that. Okay, good. I like this question, number 3. I like number 2. And I like number 1. Okay, so that's just a little heads up.